I'm Robert Alford. As a chemist, I am currently undertaking a project at Croft Engineering Services based in Warrington, looking into Dixon rings. Dixon rings are a form of random column packing, used in a number of industrial sectors for countercurrent absorption, also known as scrubbing columns, as this diagram shows, with the liquid flowing down the column and the vapour flowing up the column. Secondly, they are used as a packing for distillation columns in a closed system, with a refluxing liquid passing up into the column in the form of vapour and condensing out onto the Dixon rings, and then draining back into the refluxing mixture or removed. Dixon rings were invented by Dr. Dixon in 1946 while working for ICI. In 1946, Dr. Dixon could manufacture a small number of Dixon rings using a simple split pin and wrapping the wire around. This was of course a very slow and laborious task, and the Dixon rings could simply just not be produced in the volumes required. Croft Engineering Services, however, have now developed a way of manufacturing Dixon rings totally automated, from the mesh being fed in to cylindrical Dixon rings being produced at the rate of 1 per second per machine, soon producing the millions required for a single column. There are a number of different column packings available, which are larger than Dixon rings, but far less efficient. Alternatives include the Raschig ring. These are commonly made from ceramic or stainless steel, and were the first generation random column packing, and are only used in a few highly specific industries today, where minimum fouling is of particular importance. Interlock saddles. As we can see, they are quite an unusual shape in comparison to the original Raschig ring. The Paul ring. The Paul ring is probably the closest common packing to the Dixon rings. We can see the same cylindrical shape, but rather than the cross member, the outer cylinder is bent in, forming a tooth-like structure through the ring, offering a large surface area for the mass transfer to occur. These other packings all do much the same job within the industry, acting as a surface for mass transfer to occur. If we think of the packing like marbles in a tube, the smaller the marbles, the less free space there is between the marbles, and the greater available surface for mass transfer to occur. However, with the majority of packings, this comes with a drawback, as the smaller the free space, the greater the pressure drop within the column. If we look at this tube, full of about 10,000 Dixon rings, we can see, because of their size, with diameter and length being equal, they pack randomly in all directions, but still crucially maintain their shape. It is clear if this column was full of these 20mm Paul rings, there would only be a fraction of the number, and they would stack, producing a large number of voids. Croft Dixon rings are used worldwide in a diverse range of applications, including Spain and India, in a variety of applications, including distillation of tritium, CO2 scrubbing, biodiesel manufacture, and extraction of galathyme from daffodils, which is used to treat Alzheimer's sufferers. A new potential application for Dixon rings is for scrubbing carbon dioxide from air in submarines. Currently, chemicals such as calcium hydroxide are used to remove the CO2 from the air in the submarines. This poses a chemical hazard and minimises the time the submarine can remain submerged. This new development utilises the seawater when it is pumped through a scrubber column full of Dixon rings, countercurrent to which air from the submarine is pumped, using the same mass transfer capability of the Dixon rings. The CO2 is removed from the air and discharged into the sea. This is a very interesting area of work and could have great potential in increasing the length of times submarines can stay submerged. The potential for Dixon rings is huge, with increasing government restrictions as to what emissions industry can release to the atmosphere, and increasing regulations for chemical waste. If the current packing in a waste gas scrubbing unit is not efficient enough, the packing can easily be removed and the same column filled with Dixon rings, offering a quick, cost-effective alternative with increased efficiency. meeting regulations compared to the if the current packing in a waste gas scrubbing unit is not efficient enough, packing can easily be removed, the same column filled with Dixon rings, offering a quick, cost-effective alternative with increased efficiency, meeting regulations compared to the financial cost of dismantling and rebuilding new scrubbing units, a time-consuming process. It has been said that Dixon rings have the performance of structured packing with the ease of random packing. A simple distillation column with a solution containing water and tritiated water, boiling point of 101.4 degrees C, can be separated in a column packed with Dixon rings. The lower boiling point water will boil first, and therefore in the vapour phase pass up the column and condense out, and then can easily be removed at the top of the column, leaving tritiated water which can be as much as 99% more concentrated than the initial mixture of water and tritiated water. Therefore the volume of radioactive waste disposed of is much lower. Dixon rings are unique in that they are manufactured from woven wire mesh, which aids the formation of a liquid film over the mesh, which in scrubbing applications offers an excellent interface for the gas to be efficiently cleaned. As this graph shows, you can see the surface area of common packings, the pour ring, rashig ring, etc. If we look at the 10mm rashig ring, we can see the surface area is about 350 metres squared per metre cubed. If we then add the Dixon ring surface area, you can see that the surface area of the other packings is almost indistinguishable from the x-axis. The surface area of Croft's 3mm Dixon rings is 2,378 metres squared per metre cubed. This, along with a remarkably low pressure drop due to the large fractional void space of almost 90% for the 3mm Dixon rings, and large number of transfer units per unit height, i.e. low height equivalent theoretical plate, as low as 5.3 cm, makes Dixon rings superior to other random column packings, offering the best value for money, both in initial purchasing costs and ongoing running costs. For more information, or to discuss your specific requirements, please do not hesitate to contact us for more information, or download a technical brochure from our website, www.filters.co.uk. Thank you.